Alright, in this video we are going to clean the two most important numerical columns, at least from a commercial point of view, budget and box office revenue. So let's have a look at some meta information. And here we have the budget column, and it seems that we have no missing values at all in this column. However, we have some problems with the data type. So it could be the case that we have mixed data types here. And second, we have the revenue column, and also here it seems that we have only very few missing values, but the data type is okay and appropriate here, so we have float, numerical. And first of all, let's focus on the budget column. And actually, we could try to convert the data type into float with S type. But here we get a value error, and let's have a look. So could not convert the following string to float. And it's really a surprise that this string here is the value for the budget for one movie. So here we have really unclean data and mixed data types actually in one column. So I don't know how this can happen, but this is real life. So people put things into databases and do not really think about it. I don't know. And in this case, the S-type method does not really help. However, there's a more powerful solution, and there's the direct pandas method to numeric, and here we can pass the budget column. And again, here we get the very same error message, but here's an additional parameter, the errors parameter. And let's have a look here. And here we can either pass ignore, erase, or coerce. And with coerce, invalid elements will be set to NaN, so missing value. So actually our string here should be converted into a missing value. So now let's overwrite the budget column. And again, let's apply the value counts method. And here we can see that by far the most frequent value is a budget of 0. And obviously over 75% of all movies have a budget of 0. And this is pretty unrealistic. And we could suspect that the value 0 is actually a placeholder for a missing value. So whenever people do not know the budget of the movie, they simply type in 0 for the budget. And that's definitely not helpful, so a missing value would be more meaningful and helpful. And therefore, in the next step, we replace the budget of 0 with a missing value np.nan, and we overwrite the budget column. Next, we can see that the budget can be pretty high, actually in the millions, $100 million, $200 million, or whatsoever. And it could improve readability if we have the budget in million US dollars. So we divide each and every budget here by 1 million, and then we override the budget column. And again, let's have a look with the info method. So before we had no missing values at all in the budget column, and now we only have close to 9,000 non-missing values, and we have the appropriate data type float. Now let's go on with the revenue column, and first of all, let's analyze the column with the value counts. And also here we can see that for the vast majority of movies, we have a revenue of 0. And also this is not really realistic and meaningful. And also here we could suspect that 0 is a placeholder for missing value. So whenever we do not know the revenue, then we simply type in 0. And therefore, it definitely makes sense to replace 0 by np.nan. And also here we create the revenue in million US dollar. And finally, we should rename the column labels. So instead of having revenue, we should have revenue in million US dollar and budget in million US dollar. And let's have a final inspection here. So now we have the columns budget in million US dollar and the revenue. And in the revenue column, we finally end up with only 7,400 non-missing values. So again, identifying hidden missing values is also part of data cleaning. Alright, thanks for watching, and see you also in the next video. Bye. Alright, let's clean the other numerical columns, and our first numerical feature is the runtime in minutes. And also here we have the problem that one of the most frequent values is 0, so a runtime of 0 minutes, and this doesn't really make sense. And also here this could actually indicate a missing value, and therefore we replace 0 minutes by np.nan. Now let's check again some meta information, and here we have the movie ID column, and this could also be a numeric column actually. So let's try to convert ID to a numeric. And also here we get a value error, and it says that the value, and this is actually a date, cannot be converted. And also here we have really messy data, really unclean data. And therefore also here we have to select the most general way. So we use pd.toNumeric, and we pass coerce to the errors parameter. And we override ID, and let's have a look with value counts. And actually the movie ID should be the clear identifier for a movie. So to say, this should be the primary key. And there shouldn't be any duplicates, but here with value counts we can see that we have duplicated values in the ID column and also missing values. And we are going to handle those duplicates and also missing values in one of the next lectures. But now let's go on. And we also have the column popularity, and this is also a numerical column. And also here we have object as data type. So let's check this here. But it actually should be numerical, and the data type should be float. So let's try this out with pd.toNumeric. And also here we get a value error. And somewhere in the column we have the value beware of frostbites. And again, the only choice is to pass coerce to the errors parameter. And by doing so, we create a missing value where we had before beware of frostbites. And we override popularity, and then we analyze the column. And also here we have the value 0. In total 66 times, and this could be reasonable. So having movies with 0 popularity, that's definitely not unreasonable, and we can leave it as it is, so we don't know it better. Now finally let's have a look at the vote count and the vote average. And first of all we have the vote count, and that's the total number of votes or total number of ratings for a movie. And also here we have 0 votes or 0 ratings for almost 3,000 movies. That's not unreasonable. And let's also analyze the vote average. So that's the average rating. And actually here we have the value 0. So the average rating of 0, even if the rating is between 1 and 10. So this doesn't really make sense, and to analyze what's going on, we can do the following. So we filter df for all movies where we have 0 vote count. So here we have no voting or rating at all, and we have a look at the vote average for these movies. And obviously for all movies where we do not have any rating, the average rating is automatically 0, and this doesn't really make sense, and it's actually also not fair, because this would indicate a very low or poor movie quality, and therefore it definitely makes sense to also change these values to missing values. So for movies where we do not have any vote or rating, we simply do not know the average rating because we do not have any rating, and therefore we could create a missing value for the vote average. And finally, let's have a look again at some meta information. And now we have the right and appropriate data types for the numerical columns. So we have budget, then we have the ID, we have popularity, revenue, runtime, vote average, and vote count. And we also added some missing values, but this is also data cleaning. So thanks for watching, and see you in the next lecture. Bye.